To start, could you please introduce yourself and share a bit about your background and experience in this field?
Yeah. So my background is in aviation electronics. I began in 1965 working for a Bush operation as their avionics technician, repairing the old stuff, which you can imagine in 1965 was pretty old stuff, right? But anyways, that's where I began. Subsequent to that, by about 1975, I had my own company that was an avionics company for small general aviation, working on up to things like otters, beavers, and then all the small general aviation aircraft. And they're doing the avionics. That would be not only selling them, but repairing them as well. So a repair station selling. Then in 1985, I started another company. It was a full service type of a company, FBO. I was doing mostly the avionics, but we had aircraft repair, we had gas fuel business and that sort of thing. Then what happened then is that time from 75 to 85, then I formed my own avionics company called Avionics Canada and operated that as a standard avionics repairs, etc. Then in about 1989, there was the introduction of GPSs was coming online. Trimble was the number one company for manufacturing GPS systems. So in 1989, I negotiated with Trimble to be the first Trimble dealer in Canada for their GPS systems. And then about the same time, because I was in the aviation business, I said, okay, GPS, as it was called at that time, was the ninth utility of the world, right? There's all the different things, electricity, etc. So looked at that and said, that's interesting. So it's a utility that has both positional but also time data, right? That was it was the best time in the world was through a GPS system. So looking at that, we said, I'm in the aviation industry, how can we integrate that into it? So we looked into the forest industry and also into the mapping part of it, in other words, surveying. And so we started integrating GPSs into helicopters for going out and doing aerial surveys, specifically using cameras with integrated GPS into them. This is in the early 90s, so that we could take that data and post-process it into real map data that was being used. Mostly to do with forestry again, for cut blocks, for riparian, which is the creeks and rivers, to see how the fish bearing was, etc. And then at the same time, we looked at the aerial agriculture end of it, creating a system for that. So we started developing that in about 92, the aerial ag thing. By 94, we had some pre-production kind of units out there. And then we about, I guess, 93, we did a public company approach to my company. So we did a public company and went through a lot of development there. And then in 95 is when the public company wasn't doing what it was supposed to do for us. So then I left it. It was my company, but I left it and formed my current company, DynaNav Systems, in 1995. So we're coming up on 29 years of a company that concentrates on aviation only, electronics specifically, based around GPS, based around mapping, based around guidance for like the agriculture industry, forest industry, etc. And then as time went on, we then got into, of course, control systems, flow control systems, gate control systems, etc. We had clients in Germany that did liming with helicopters, and they needed some special software and control for that kind of application. So that even further got us into more of the helicopter end of that. In the meantime, we also went into the oil and gas exploration products for helicopters, and we created a system called DynaFlight Size Bag. And what it was for the purposes of the helicopters to be able to pick the equipment up on their long lines and bring it out to the forest and drop it on the exact spot as they're supposed to do. So they had these carousels with 6 to 8 different bags of equipment for size bag, and they go out and start placing these on these pre-surveyed points, right? Some of it was in what they call triple closed canopy, which means that the pilot can't see the ground where he's putting it, but he would know the survey spot, so he'd find the clearing as much as he could and go and put it down on the ground. He couldn't see it on the ground, but he could feel that he releases it. Then later on, the guy in the ground would want to package everything up and get it picked up. So now he would go back to the spot, because we recorded it, and lowered the thing down. The guy in the ground couldn't see the helicopter. He couldn't see the guy in the ground, but they had communication. So he keep lowering it down. The guy say, okay, snapped it on, away you go. So it became a very fascinating, because these were in jobs that the primary reason they're using the helicopters was what they called zero impact or low impact environmentally. So in the environmental end, they were no longer allowed to cut down big trees and etc. that they used to for doing this geophysical type surveying. It went into the point that they just didn't allow it anymore. So through this helicopter, we're using our technology, they were able to very efficiently, and they found out that one company, huge company, did a big job, used 4 helicopters with our systems on, and they compared it to before they had those systems, and it was something in the order of about a 15% increase in productivity by having this technology, right? I wished I had that money that they saved, but anyways, but the systems are great. So it gave us a lot of experience again in helicopters, navigation, and etc. on that. And then we carried on again in the aerial agriculture industry. And that's our primary focus. All we look for is solutions. The number one issue on our thing is all to do with pilot safety. So when we looked at pilot safety, the primary thing is that number one, something that doesn't distract him from what his job is, which is flying the helicopter or the aircraft where it needs to go. So one of the things that we did when somebody wanted some kind of a feature, we'd ask 2 questions. First question is, if we have that in there, how does it improve the pilot safety? You have to answer that. Second question is, how does it make you money? Because if it makes you money, now you're interested in the first thing we asked, pilot safety, right? So we look at that. If we didn't feel that it was going to improve both those, we wouldn't do it. So our issue then is we also said that the system had to work with the workflow of what the pilot needs, right? That way he's not, doesn't get caught up in any particular stage of something and then say, oh, what do I do? So we designed the system around workflow. And the other one was that I had the big sign in our software engineers is the KISS, right? Keep it simple, sound, or stupid, whichever way you want to be, right? So it was very important from that end of it to keep it simple, because the big thing often is called the learning curve. And during that learning curve, the longer it is, the more unsafe it is, right? From the pilot's end of it. You don't want him frustrated. You don't want him to be sitting there, okay, now what do I do? And start concentrating on it. So when you look at our systems, you're going to find the biggest thing that all of our pilots that get it say, it's intuitive, it's simple, it's easy. So we have a thing that's, I have no idea what that is, but anyways, and it's called Simple by Design, Flexible in Application. And that's our driving way, it's our motto of what it is. It's got to be simple by design. In other words, we design it to be simple, but the system is extremely flexible for the pilot to be able to get and do what they need to do without having any large stress. So to that, it finally culminates in the last product that we're releasing at this show, and that is the heads-up display. To me, for most everything that's out there, just about everything, in one form of helicopter to fixed wing to whatever, usually has a solution that they can go out and do the job. The other part to that, of course, is the when you look at the pilot and the information he has, he can also have other information available to him to make these very rapid decisions. A remote's not, it's just not there at all. So to me, most of what's going to ever happen has to be the pilot. But so for me, that's the big issue. Drones are good. They're great in certain applications, and certain parts of the world for certain things. But that's it.
As the industry evolves, larger drones are being developed, raising questions about cost effectiveness and their potential to replace pilots. What do you believe is the best way to balance innovation with preserving pilot roles and ensuring the cultural acceptance of these advancements among farmers and operators?
Yeah, again, my opinion, one example is there is the concept that you can add in an autopilot into an aircraft that has a pilot, do an aerial agriculture. To me, there's absolutely no point in it. If you needed to have that, then you should not have the pilot in there. But you can't have it without the pilot in there for the reasons that we all know. All these nuances, the drift things, what's going on around them, buffeting. There's certain things that can affect the spray pattern. He'll know that right away. He'll see a temperature inversion. He will understand that as a pilot, whereas remote aspect of it isn't necessarily there. So, to me, the other part is with our equipment, we have proven that the pilot can actually do it more accurately than you can with the autopilot. So, what is it? Well, the difference is the right presentation of information. And as I referred to earlier, most important part, to make it simple and easy and intuitive, you have to have something presented to the pilot that is that way. In our case, we present the roadway. The guy flies a roadway. The example of that is that normally, if you find on the light bar systems, if the guy's right on the deck, he seems to be pretty accurate, not bad, he's there. The higher he goes, the more inaccurate he becomes. He's trying to chase the light bar, and he starts becoming inaccurate. With our system, with the roadway system, we bring the roadway up wherever he is. We had one contract that was done for the American military in a helicopter that had to fly 5,000 feet above the ground. He had to fly 5 miles in one direction on a line, turn, and do a 3-mile run. And he had to repeat it over and over again so they could check all the data, okay? And as it was, with his helicopter up at 5,000 feet, his general accuracy was within 3 feet. That whole 5 miles and the whole 3 miles. And how did he do it? Because we gave him the roadway presentation to fly this thing down. Other than that, at 5,000, you could never, in a light bar system, be able to, you'd be all over the place trying to chase, because you haven't got that horizon world to work with to keep yourself stable. This thing keeps them stable, right? So the accuracy's there. We don't have to worry about that. We have to worry about the pilot with his eyes out the window and watching for all the obstructions, towers and telephone this and wire this and school bus that, etc. There is only one person who can do that, and that's the pilot. No autopilot's ever going to do that. No AI is ever going to. Well, if it is, it's in a world we don't know about yet, right? It's a whole different thing. And the pilot, believe it or not, why would you want to get rid of him? He's the cheap part of the whole thing. Chemicals are more expensive. The airplane's more expensive. All that's more expensive. Pilot's okay, do the job, and if you do it right, and we can see if you're doing it right live even, you can sort those guys that with their technology today, you can find the good pilots. If you're not a good pilot, you're not for us, right? That's the key. If you've got enough information recorded, enough to see what's going on, now you can start making good decisions of who's flying those airplanes, right?
When it comes to traditional spraying aircraft like air tractor, thrush aircraft, or Embraer models, what small but important improvements do you think should be implemented to enhance pilot safety and increase application efficiency?
Again, I'll go right back to the latest thing in our show called the HUD. Heads-up display. It's a true projected display technology. In other words, we project it out into far vision. So like in a fighter aircraft, they have HUDs, but where it is, it's actually in far vision. So when he's flying out there, it's visible to him all the time. So we do the same with this roadway navigation. And as a result, it's very comfortable, smooth, accurate, etc. from the pilot's end of it. Less stressful, obviously. And he can go down and get this thing on and then pay attention to that outside world, right? Because he doesn't have to be focusing in and out. With our systems, we also had it important that in the grip, we have a top hat and an enter switch that 100% runs that upper display system. He can do everything from select customers, select jobs, changes patterns, do anything he wants can all be done through that upper screen. So he can keep his eyes out the window in far vision and leave it at that. If he needs to get inside to look at his instruments for the purposes of the engine stuff, anytime he can scan in and out, it's not an issue, right? And he's only going to do that, not when he's on the deck. When he comes and pulls up around, he's going to do his scan, come back out. The thing's going to give him exactly what he needs to see in the turn. It shows him the turn, shows him the intersect angle. Everything's all graphically presented. We use colors now in the heads-up display to give differences on certain things. One of the ones that was discussed today was somebody would say, well, what if we went in and mapped power lines and stuff like that? Could we present it? I said, yeah, and one of the things we could do with that is just to make it a different color, right? So it's identifiable from the pilot, and oh yeah, okay, there's a power line coming up because it's in their map. But nothing flashing, anything like that, because you just, first thing is to never distract the pilot if you can possibly not distract him, especially when he's down on the deck going flying along. You don't want to have anything. So there's other things that we can do, and it's from the pilot end of it to improve his environment, improve the safety, is to have audio alerts, certain things, because audio alerts are not that distracting. Everybody's used to audio thing, but give them some information, extra information about something that's not working right or whatever, but something that it doesn't suddenly give him a visual distraction there, because he's got to pay attention for people in the field and, as they say, vehicles and towers and lines and everything else. Keep the eyes out there. So with our new technology, it will be a huge improvement relative to the pilot safety and their accuracy. And the other thing is of course, is only putting the information on the HUD that the pilot needs for his operation. No other stuff. He doesn't need anything but what he needs, such as ground speed, what's the flow control working, the boom pressure is good, that sort of thing, his guidance, of course. And so that should be all up on the screen. Yeah, so I think that's the important thing.